In the last lesson, we talked about the traditional method of grading timber using F-grades. This system works well for most species and is still used for all of the hardwoods and various softwoods that are used structurally, such as Douglas fir. But over the years, it was found that F-grades weren't always accurate in predicting how the plantation pines would perform in a structure. These species include radiata, slash, and Caribbean pine. Pines are knotty by nature, and the F-grading system was tending to understate their performance in actual wall frames and roof trusses. So a new set of grades was developed just for this particular group of pines, called MGP. The MGP system is based directly on the modulus of elasticity of the timber. You'll recall that in the last lesson we said that MOE is a measurement of stiffness, and the higher the MOE, the stiffer the timber is. Basic MGP machines work like F-grading machines, since they still bend the board and measure its resistance to deflection. But instead of calculating an F-grade via an assumed modulus of rupture, they simply state the MOE category that the board falls into. For example, a board graded MGP 10 will have a minimum MOE of 10,000 megapascals. MGP 12 has a minimum MOE of 12,700, and MGP 15 has a minimum MOE of 15,200. More modern machines use sonar and X-ray technology to analyze the timber and assess its strength, reducing defects. This information is processed by the scanner's computer to calculate an MGP grade. If you're working with span tables or building plans that specify F-grades, you can use MGP 10 to replace F5, MGP 12 to replace F8, and MGP 15 to replace F11. However, this doesn't mean that you can use the same substitution process in reverse. That is, F-graded material can't be used where MGP grades have been specified. The reason is that F-grades were only ever designed to assess the bending strength of a piece, and any other properties, such as compressive, tensile, and shear strength, are assumed to be more or less proportionate based on the board's grade. By contrast, MGP design tables cover a wide range of properties, and engineers have all of these attributes at their disposal when they're making design calculations. So when a certain MGP grade is specified for a structural member, it could be based on factors other than simply its safe working stress in bending.